Hello. All right, so this is a continuation of quarantine assignment number 7. So this is the second part of logarithms. So this is going to be the last assignment that's going to be on logarithms. So that is quarantine assignment number 8. Okay, so in the last assignment, if you did it, we covered these following logarithmic rules. So if you need to look at all of these rules, please look back at quarantine assignment number 7. Okay, now let's try to expand your knowledge based on logarithms. So let's say you were given log base 4 of x equals 3. Now, how would you solve for x? So what I'm going to do is I'm going to introduce a new rule to you. So this new rule, a base with a logarithmic power rule, is going to be if you have a base and you raise it to some log with the same base of x, it's going to equal x. Okay, so our first example, log base 4 of x equals 3, solve for x. So one thing I see that we can do is, let's say I just write that here. Log base 4 of x equals 3. Okay, so what we want to do is, if you look at my notes, if you didn't understand how to do this, we want to raise both sides with a base of 4. So we want to rewrite the expression with a base of 4 on both sides. So we're going to rewrite this, same thing, but we're putting 4s underneath. Okay. Now this expression here looks like this one, except the b is equal to 4. So if you see a pattern that looks like this is just x. So x equals 4 cubed. And then if you try to do it, 4 times 4, evaluate 4 times 4 times 4 is 64. So x equals 64. Okay. Now, so if you recall from the other assignment, another way that you can think of log base 4 of x is by defining your base, answer, and exponent. So if you guys remember Mr. Cam's method, right? B, A, E. This is your base, this is your answer, and this is your exponent. Okay, so if the exponent is 3 with a base of 4, what is our answer? So if you had to rewrite this, so if I were to just do that on the side here, if the exponent is 3 with a base of 4, what is our answer? Okay, so this, if you noticed, is the same thing as that. So the reason why I want to show you this way is so you guys understand how the math behind it works. So like when you do something to the left hand side, you got to do the right hand side, but then you just have to memorize this formula. Okay, all right, so we have the same problem. So now this one, log base 12 of x equals 2. You want to solve for x. Okay, so what I see here, I'm just going to rewrite log base 12 of x equals 2. So we have a 12 here. Just like this example here, since we have a 4, we have to rewrite that expression with a base of 4 on both sides. For this example, we have a base of 12. So we have to rewrite this expression with a base of 12 on both sides. So the 12 comes right underneath. Okay. Now, using this formula I showed you earlier, b raised to log base b of x, this is just x. So this part here, this part just simplifies to x, which is 12 squared. So 12 squared, 12 times 12 is 144. Okay. Now, again, if we did it the way that Mr. Cam does it, so you can think of it as log base 12 of x equals 2. This is your base, this is your answer, and this is your exponent. So, in other words, if the exponent is 2 with a base of 12, what is our answer? This is the same thing as that. Okay, so just a couple different ways. If you prefer to just memorize it using a formula, you can. Or if you would rather understand it by seeing things happening to the left hand and right hand side, do it that way. Yep. Okay. So next I'm going to show you some examples. So solve for x. Okay. So what I see here is, since I have a base of 7 here, this is 7 log raised to log base 7 of x equals 7 raised to the 4th power. This part just turns into x equals 7 raised to the 4th power. And if you do that correctly, x is going to equal 2,401. Okay. Next one. So if we see this here, our base is 11. Since our base is 11, is 11 log base 11 raised to the x equals 11 squared. Okay. This part would disappear. We have x equals 11 squared. So x equals 121. Okay. This one, we have a base of 2. This means we're going to rewrite both sides with a base of 2. This part would disappear. X equals 2 raised to the 5th. So x equals 32. Okay. This one. Okay, so log base 6 x equals negative 3. Rewrite both sides with a base of 6. Oh. Yep. Rewrite both sides with a base of 6. So 6 log 6x equals 6 raised to negative 3. This part simplifies, so x equals 6 raised to negative 3. So x equals, so 6 raised to negative 3 is the same thing as 1 over 6 cubed, which is the same thing as 1 over 2, 16. Okay. Log base 10 of x equals 1. Same idea. Raise both sides with a base of 10. This simplifies. X equals 10 raised to negative 1. X equals 1 over 10. Okay. This one. Our base is 2. 2 raised to log base 2 of x equals 2 raised to negative 4. This simplifies. X equals 2 raised to negative 4. X equals 1 over 2 raised to the 4th power, which is 1 over 16. Okay. This one. This one's a little bit harder, not too much harder. So this one, 2 log base 2 of x minus 4 equals 2 raised to the 6. Our base is 2. Put a 2 underneath. This part here, this part will simplify. So think of this expression as a variable. If this whole variable comes down and this cancels out, we're left with x minus 4 equals 2 raised to the 6th power, and that is 64. Okay. Then we want to add 4 on both sides. And we add 4 on both sides, x equals 68. Okay. This one. So what we want to do is same idea. We have a base of 3. This thing will cancel out. So we have 2x minus 7. 3 raised to the 4th power is 81. Add 7 to both sides. Then divide by 2. X equals 44. Okay. This one. So same idea. Our base is 4. 4 log base 4 of 2x minus 6 equals 4 squared. This part will cancel. We're left with 2x minus 6 equals 16. Add 6 to both sides. And then divide by 2. There we go. Okay. Next one. So use logarithm rules on the first page. So using the logarithm rules here. So we're going to specifically look at these ones. Okay. So using the logarithm rules on the first page, condense into a single logarithm. Okay. So what I see here is for this problem here, I'm going to use this example. Log base b of m raised to the r, this exponent comes right in front. Okay, so instead, if you look at this, the exponent's already in front. If we want to write this as a single logarithm, we have to do the opposite. So if we're doing the opposite, this will come up here, and this will come up here. Okay, this is log base 4 of 8 cubed minus log base 4 of 2 raised to the 5th. Okay, so what we need to do next is, what I see here is I can actually simplify this. So 8 times 8 times 8 log base 4 of 512, I think. And this is log base 4, 2 raised to the 5th power is going to be 32. Okay. Now what I see is we're going to use this rule. So that rule is used for subtraction. So this is log base 4 of 512 divided by 32. Do this correctly. This is log base 4 of 16. Yeah, you could even go further. You could say, because this logarithm is an exponent, 4 squared is 16. Log base 4 of 16 is 2, if you wanted to write it as a whole number. But I'm just writing it as a single logarithm, so this is just log base 4 of 16. Okay, this one. So this one I see is a combination of multiplication, and division. Okay, so what I'm going to do is I'm going to first take this one. Okay, so I'm going to first do that. So we have log base 4 of 8 divided by 4 plus log base 4 of 6. 8 divided by 4 is log base 4 of 2, log base 4 of 6. Now this becomes a multiplication, because this is log base 4 of 2 times 6. This is log base 4 of 12. Okay, this one. What I see here is we're going to work with the parentheses. So parentheses first. So this is 2 times log base 6 of 45 over 5. And then plus log base 6 of 3. 45 divided by 5 is 9. So this is 2 log base 6 of 9 plus log base 6 of 3. Okay, now we're going to do opposite of that power rule. This comes on top. Log base 6 of 9 squared plus log base 6 of 3. 9 squared is 81. Log base 6 of 81 plus log base 6 of 3. Now we're going to apply the multiplication rule. So when we apply a multiplication rule, log base 6 of 81 times 3. So this is log base 6 of 243. Okay. All right. Next one is the next couple ones are a little bit more challenging. They do it variables. Some of them do it variables instead. Okay. So same idea. Like I said earlier, we're going to do the opposite. So for power rule, we're bringing this up here. We're bringing this up here. Okay. So we have log base 5 of x raised to the 7th plus log base 5 of x squared raised to the 4th. Okay. So x squared raised to the 4th power. If you guys remember that from quarter 3, that is just x to the 8th. Because 2 times 4 is 8. Now we use the multiplication rule. We're using multiplication rule. We're doing x to the 7th times x to the 8th. So this is log base 5 of x raised to 15. Okay. All right. This one. Okay. So same idea as the first one here. So we're going to group it together. What I see here is this is log base x. We have a addition symbol, so we're going to multiply. 7 times 10 minus log base x of 5. 7 times 10 is going to be 70 minus log base x of 5. Okay, so next what we're going to do is, I see we have a subtraction symbol here. Because we have a subtraction symbol, it's the same thing as log base x of 70 divided by 5. Do 70 divided by 5 correctly, this should be log base x of 14. Okay, I'm going to do this last one, and we'll just cut this video short, and I'll give you the next part after. Okay, so what we have here is we have 2 times log base 9 of 2 plus log base 9 of 4 minus log base 9 of 8. Okay, so same thing. Do the parentheses first. We'll do parentheses first. 2 times log base 9 of 2 times 4 minus log base 9 of 8. Okay, 2 times 4 is 8. This is 2 log base 9 of 8 minus log base 9 of 8. Okay, so if some of you see a shortcut here, you could just do, if this is x, this log base 9 of 8, if you just consider it as x, this is just combining like terms. So the answer should be log base 9 of 8 if you just subtract this. But let's go ahead and prove that. Okay, so we're going to do the other way. So you take this number here, rewrite it with an exponent. Log base 9 of 8 squared minus log base 9 of 8. 8 squared is 64. So log base 9 of 64 minus log base 9 of 8. Subtraction means that we have to use division. So this is going to be log base 9 of 64 divided by 8. And we are left with log base 9 of 8, which is exactly the same thing I mentioned earlier if you just combine like terms here, if you saw that. Not very obvious to see that if you were just trying to use the rules though. Okay, and that's pretty much it. Okay, so let me know if you have any questions.